Hey everybody, welcome to Houdini Hangout. We're at the end of July. It's the 26th. And welcome to you. Hopefully you're having a great Wednesday or Thursday or, whenever you happen to be watching this. Hopefully you're having a great day. So today we're going to be talking a little bit about some kind of flowy cloth simulations. Some suggestion that was on one of our topic suggestion kind of forum things on the Discord server. Just a little link there in the chat if you want to check that out. That is where you can find the Discord server. And so what we're going to be doing tonight is going to be probably setting up some zero-G cloth and kind of just poking it and prodding it and making it kind of move around, however we see fit. However, there's probably a few different levels to which we can kind of take this. And I'll talk about this a little bit as we're, messing around with it. And we'll go from there. But something really fun, just as a little side note, as we're kind of, ramping up here into the evening, I am excited because I finally am learning how to use GitHub, which is really cool. And our education team has some really cool tools that are going to be coming out for any of those out there that are, interested in doing educational videos or things like that, or just teaching people more about Houdini and about, some 3D assets or whatever that you might, topics or things like that you might want to teach about. We're going to have a whole tool set coming out. It'll be small at first, but should be pretty cool. And I'm excited because I'm, at this point, I haven't really added much to it, but we're all going to start adding some different tools and things like that to this tool set, and should be pretty neat. So keep an eye out for that in the coming weeks. I'll probably be talking about it because I think we're going to probably push it live onto the Side Effects GitHub at some point, but should be there and be kind of interesting. Not really production tools, not things that you would use for doing fancy, explosions or simulations or anything like that, but certainly some really cool stuff for teaching and training and things like that. So keep an eye out there. Should be pretty neat. Also tonight I figured out how to stream to another place tonight. So as far as I know, yeah, we're also streaming. Apparently LinkedIn has streaming, and so I'm streaming on LinkedIn as well tonight. I just randomly saw that in my list of restreamable places that I could do. So I was like, well, I guess more exposure can't be a bad thing. So we're going to try that out, see how that goes. But I doubt there'll be too much engagement there, but hey, maybe somebody will stumble upon it through that. So that could be cool. Anyways, so kind of a fun little detail to add into this. So let's take a look at maybe what specifically we're thinking about making tonight, and we'll kind of go from there. So the suggestion was, let's see here. I'm just gonna go over here, and I probably should have streamer mode on or something. That's all right. It'll be fine. I don't think any issues will come up here, but the idea was to do something like these here. He had a couple little links and things like that. So I was like, oh, that could be kind of cool. So I loaded those up, and these are the different videos. So this one's kind of neat. It's got like a bunch of like boxes and things like that that are just kind of floating and squishing in space. So that's kind of cool. Kind of a neat little simulation there. So that could be kind of neat. I might try to put in a few of these like kind of not seams, they're kind of like scrunched up sections of cloth. So I might add a couple of those in just to see exactly how that'll work in a simulation. But so that is one thing that was one of the suggestions. This is another one. This is, I think, quite a bit more advanced than something that we'll do tonight on the stream, because like as I'm looking at it, I'm like, oh yeah, okay. I was kind of thinking of it going one way just from those stills, and then seeing these, I'm like, oh, I kind of forgot about these videos because I pulled these up right before we went live. So I'm like, oh yeah, these are quite a bit more complex or whatever. So I said that really weird, complex. Anyways, so these, we certainly could do something like this. Really the question is, how deep do we want to get with it. So we'll kind of see where we get with it tonight. I think what we're going to do is try to get a little bit more of this like flowy kind of randomy animation going, and then we'll go from there and see if we can have it transform and do that type of a thing. So that is the idea that we're going to, fingers crossed, we'll get somewhere with that tonight. But the other thing that I always try to say before, getting too far into a stream is that if you have an idea or suggestion or thought or anything like that, please feel free to drop it in the chat. I am definitely always... Hey, Lignazio. Yeah, you're up. Well, hey, hang out for a little bit until you fall asleep, and we'll always be... the recording will always be here tomorrow, but glad to have you with us. What I was saying was, if you have any thoughts or suggestions or ideas or anything like that, please feel free to drop those in the chat. This is not me trying to say this is the only way to do this or this is my idea. Kind of coming at this, open-minded with a lot of different thoughts kind of going around in my head. So certainly I'd love to hear from your guys' ideas or thoughts, or, hey, what if we tried this? Or what if you did that? Like, that's kind of the idea of these types of streams when we're talking about just like a kind of open-ended topic like this. I want this, I'd love for this to be something that we can all kind of mess around with and play around and kind of see where we get with it. So that's the idea here. So that's what we'll do. And if you guys have questions or thoughts or ideas or think I'm doing something stupid, please put it in the chat. Love to hear. Always up for being challenged or, suggestions or whatever. I know last time, Crossfader was on here and he mentioned something about like, hey, I think you're doing that too difficult. Just use the normal. And I'm like, oh yeah, I'm over engineering this, aren't I? So always open to good suggestions. So anyways, with that, I guess let's dive in a little bit. I'm also going to adjust. I've got a fan over here that hopefully is not making too much noise at least. Just going to get that so it blows on me a little bit. Hey, Zach, how's it going, man? Welcome to the stream. All right, so let's do some sims and set some stuff up. So I think what I'm going to start with is I'm just going to start with a box here, just a simple box, and that puts a geometry node down with a box inside of it. That's kind of a little bit of a little quick shorthand there. But so we got a box inside of here, and we don't really need to worry about where this is positioned in space because it's going to be 0G. So we'll just kind of let it be at origin like this, above and below. Maybe we'll try something a little bit like these, where they have some of these like longer type of things like this. I mean, that's a pickle, which is really weird. But a lot of these are kind of these taller boxes. So maybe we'll just do like a tall kind of squarish shape. Cube shape, tall cube, I guess. So let's do that. We'll just start with this maybe at like 1 and, I don't know, 5. How's that look? Yeah, that's pretty good. Maybe we'll do 4. Something like that. Cool. All right. Actually, you know what? I am just going to... Sorry, I'm just checking something here. Take this over here and just see if I can adjust this a little bit here. I just don't want that to show how many times I'm clicking something here. So talk amongst yourselves for 1 second. I just want to not have that showing so much. Didn't like that. Sorry. There we go. I think this is what I want. Just sick of this thing showing multiple texts as I'm typing here, so. Yep. Oh, well, I can't find it. Anyways, let's just get into it. Here we go. So let's do our kind of traditional remesh type of thing here. Let's do that. Get a little remesh going on this. And that's going to give us this triangulated mesh. We don't have to do this step. It's not required. We could just have quads, if you remember back to our Vellum talks. But this is kind of the more, this is the better way of doing it, I guess you could say. So we'll just stick with that. All right. So let's do a. Just trying to think of what specifically I want to do. Let's do a Vellum configure. Let's do a maybe just do a Vellum configure. Let's do a strut soft body at first. Let's just see how that works. And we'll kind of go from there. So what this is doing, again, just as a reminder, is it's adding constraints for it to be now looked at as cloth, a Vellum cloth constraint. And then we're adding struts, which are basically going to be connections inside of here. That's going to make this into a soft body. So it's going to be kind of have a volume that is going to try to keep, it's going to kind of have this connection between each other on either side of the geometry. But it's not going to be quite like a tetrahedral soft body where it's going to be like fleshy, and it's not going to be like a balloon soft body where it's going to have this like you squish one side and the other side like pressures up. It's just going to give it a little bit of rigidness to this soft body. So I think this is going to be what we want and should get us to a sort of interesting place here. So let's put down a Vellum solver, and we're just going to kind of be working with a bunch of these different settings and things tonight. So we've got our Vellum solver here. Now, if we hit play here, this should just fall down because it has gravity. Obviously, we don't want that. So let's do the easy thing first and turn our gravity to 0. There we go. So that's nice and easy. And we can turn our wind off here as well. That should be fine. We can turn that off because we're going to do a lot of forces and things like that inside of our solver. So let's jump in here. And let's take a look at what we're going to do here. So let's do a pop wind. Now pop, the reason we're using these pop forces is because these are acting on points, and they will kind of move in. It'll move the points around, and since we're working just with points in Vellum, that's going to get us the data that we want. So let's take our pop wind here, and I'm just going to add in some amplitude. Let's just get some amplitude going, and that'll start to make this a little bit more interesting. It might be actually a little too much. Let's just do 0.25. We'll leave this pretty much everything the way it is right now. I'm just going to up the pulse length a little bit to maybe like, 5 maybe, just so it's nice and slow at first. And let's see kind of where this starts to go. Oh yeah. We're getting just some barely any movement. So let's go a little further with this. Let's go up to 1. See where that gets us. All right, we're starting to get some movement here. So let's bring the swirl size down a little bit. It's going to make the swirls closer together. So let's start kind of playing around with this and seeing where we can go. The other thing too we should probably do is reduce the strength of those struts internally so that we're not so that it's not so rigid. So let's mess around with that a little bit here. So we have our strut stiffness here. We've got our cloth. That bend stiffness and the stretch stiffness are both good. I think those will be what we want. And let's actually just turn off these struts for a second just to see kind of how strong this actually is working here. So yeah, we don't have really enough going on with our cloth yet. So let's really push that a bit more. Let's say 5. I don't know. Yep. So that's now actually affecting this cloth quite a bit. Now we don't have those struts inside, so it's not causing it to actually move around, but we're getting somewhere with it. We're starting to see this, kind of do its thing. It's starting to actually get some forces applied to it. So instead of that, let's try something a little bit different here, because we don't want it just to have random noise moving on it, right? Hey, GMZ, welcome to the stream. Welcome. Glad to have you here. So we don't just want it to be just this kind of random noise all over the place. Well, that's good. Usually you want to add that in as kind of an effect after the fact, right? You don't want to have that being something that's specifically driving the simulation. If we look at some of these things, like for this one, for example, here, we have these kind of twisting forces, right? And there's a twisting force going in one direction, a twisting force going in another direction, and a last one up here, twisting force going kind of in this final direction. So one thing I'm going to do is I'm going to make the target size a little bit smaller, just get a little bit more resolution out of this mesh. Maybe 125, something like that. And let's just see how that looks here. Oh, right. We took the force out. So let's now do let's just do a line here for a second. And what we're going to use is we're going to use this, we're going to go back in here and use the pop, curve force. And what we can do is we can actually have it orbit around a curve in our space, right? So we can bring in this pop curve force here, and we could bring this line in. So where is this line currently? This line is just vertical right there, right? So if we look at this, we can see that it's kind of right there. So that's good for right now. And let's give it maybe a couple more points. Maybe we'll do like 8 points on it. Something like that. Cool. Let's do a null here. And we're just going to say curve force. Something like that. We'll go back inside of here, and we're going to grab this pop curve force. We're going to click on this SOP path here. Let's look at this operator so that we're going in the right spot. And what we want to do is we're just going to collapse that. That's the Vellum solver. So let's just grab this curve force here. So now what you're going to see is that there is a force that's operating on this simulation. Now you can see there's wireframes of this. We can turn the guide geometry on or off. But what we can do here, and we've played around with this a little bit in the past, is you can change the scale of all of these different forces that are going to be acting on it. So like, first of all, you can change the radius of it. So we could change it to more like, I don't know, something like that maybe, or, you could leave it where it is. It's fine. The other thing that you can do is you can adjust the force along the length. So in this case, we should be seeing the force go down as we go across the length of this. So here we could add some points in. We could adjust this down, move this in a little bit, and you'll see that this is now kind of turning this into this dark color, right? And so what we can do is we can actually adjust where these forces are going to be stronger, higher or lower, basically. So this is going to allow us to be able to adjust along the length of the curve. And then this is the global fall off from the curve. So this would be the force along the length. So we could do something like this and just kind of see where this goes. Just kind of give it a bit more fall off on either side of it and see how that works. But what this should do is start to actually orbit around on this. So we're going to actually have an orbiting force here, right? So now we have this force being added. And it's actually, it's actually doing something here. It's rotating the whole cube, right? So that's kind of interesting. But if we did something like, let's make this line a little bit shorter. Let's do it like 0.25, something like that. Oops. And just take a look at what this looks like. So now it's just a tiny little curve in the middle there. And if we go into the Vellum solver, we can now see this is even smaller. And we should be able to see this affecting a bit more just in the middle there. The other thing it's doing is it's actually following along this line, and we kind of don't want it to do that. So I'm going to turn that off. I don't want that to happen at all. All right, so we're getting some interesting results here. I'm not exactly sure why they're happening, but that's okay. Let's kind of play around with this a little bit more. Turn the strut back on. Just making sure I'm not, let's reset this and just make sure I'm not doing something that I'm not meaning to do. Cool. Okay. see if we set that the other way, if that will. Nope. So a couple things that you'll see here is that this is actually going to suck. This is a suction inwards. Oops, went all the way to the end there. And let's do just adjust this a little bit, the influence radius, and see where we can get here. Yeah. So that is going to be really what we're going to want to do here is adjust some of these orbit scales and things like that. So let's also add a pop drag in here just so we have a nice like kind of drag force that's acting on it as well. Make sure we're not just grabbing everything and moving it around. Let's see if we put that after the fact here, if that makes any difference. Okay. I'm just going to check a couple of these settings in here. So we have our thickness set for our cloth. Let's double check this. Just want to make sure all of our settings are good here. Yeah, that's fine. Let's set the mass to do calculate uniform, and we'll set it at a density of like, I don't know, maybe like 250 or something like that. Or no, it's probably a little too high. Let's do it at like 100. There we go. Now we're starting to get somewhere. I think the problem was that everything was just so light that it was just moving it all simultaneously. It can happen sometimes with these types of simulations. So we want to give it some density so that it's actually able to move and do things like that. So what you're seeing here is it's actually it's scrunching in because of this suction scale. So if we undo that, we should see less pulling in and more just rotating around now. So that's something to keep in mind there too. So what we could do is we could have a couple of these forces acting on it. So I'm going to bring up the help actually for this pop curve force because I think there's a couple things in here that we can use to our advantage. So let's take a look at this here. So there should be some stuff in here that talks about the attributes. Let me just see. Maybe it talks about them on the other one. There's another. Just see if this one has the information on it, because it should say there should be some attributes that we're looking for this. Nope. Because what you should be able to do is set which direction and things like that this goes with these individual scales. Let me just see if it actually says it in the parameter section, because it might say it there too. Here. Nope. All right. I thought that there was a thing that we could do in there. So let's just play around with this a little bit here. Because we're going to want these each to go a different direction. So let's do this. We'll do a couple different of these. We'll just add a couple forces in here. We'll say, we'll just call them curve force. Sure. 1, curve force 2, and then maybe curve force 3. Sure. And what we'll do is we'll set each of these to be in a different section of this. So that's right there. Let's do, just move these all together so we can see them all. It's purely just for some visualization. We'll just set each of these kind of at different spots. Cool. Something like that, maybe. And then what we can do is we can set each of these to kind of go in a different direction. Oops, sorry. So we'll go back into the Vellum solver, and this will be curve force 1. We'll have a couple different forces in here. We could do it in line, or we could do them all merged together. Kind of 6 of one, half dozen the other. Shouldn't make too big of a difference here. So let's grab each of these, and we'll kind of start to make some different forces here. So what I'm going to do is I'm going to do the middle one as a negative orbit. So let's do this as like -5. And then these will be 5 and 5. Maybe I'll just slightly vary them a little bit. Well, we'll do that in a second, but let's just get this started and then we'll go from there. So there we go. We've got some kind of crazy stuff, and we're going to have to animate these. We're going to have to, kind of tweak them and make them, do what it is specifically that we want. But we're going to start getting this kind of twisting, swirling motion. And once we kind of give it that, we impart that motion into it, we're not going to want to keep it there, right? We're going to want to let it. Hey, Ruben, thanks for being on the stream. And so we don't want to just give it that motion and then keep twisting it in that direction. We kind of just want to give it that impartation of the force and then be done with it. So what I think I'm going to do here is just kind of, we'll give it like, I don't know, maybe we'll give it like a second to do its thing, and then we'll just kind of let it float and take the resistance off. So what I'm going to do is just kind of select all of these here. Gonna keyframe the air resistance, and then here at 24 I'll keyframe it again, and then maybe by 36 or maybe by 48 we'll just kill them all off like that. And we'll just kind of give it a second here. So let's see what this does. Yeah, so it springs back, which is definitely not what we want it to do. We want to give it less of that springy, like less of that ability for it to spring back, which will be in some of these settings here. Like the Vellum struts are actually probably going to work against us a little bit here. So let's tweak that. And again, I want to see all of these. So I should keep that there just to be able to visualize it. And I'm just going to see where these kind of sit in here, and I'm going to adjust them a little bit accordingly. So I actually want to bring them each up maybe a little bit here. So maybe this one we will leave at 0. So we'll bring up a little bit. Just going to kind of center them out as best I can. Also, now that I'm thinking of this, this is the center one. This should probably be, whoops, I should just change the order of these. Just shaking those to, so this middle one will be our curve force 2. And then, there we go. So that should be a little bit better. I'm just going to line these back up. Cool. All right, so we have curve force 1, 2, 3. Now we have them slightly offset. Oops, I keep going up for some reason. I don't know why. So now we have them offset. They're a little bit more centered. That should be good. Let's play around with this a little bit now and see kind of where that gets us. Yeah. Okay. Cool. Yep. Looking good. All right. So with the struts off, it's not going to quite push all the way back out. But let's also look at our Vellum cloth settings, because these are going to be important as well. So we probably don't want the bend. We want to reduce the bend stiffness. So let's turn that down a bit. And can probably reduce the stretchiness of the stiffness a little bit too. So let's do that. We could let it stretch a little bit if we needed to. The other thing we should probably do is just maybe give it an extra sub-step and maybe up the constraint iterations just a little bit, just to give it a little bit more fidelity. Then that'll allow it to be a little bit more active. Okay. Let's see here. Let's give it a little more weight and see if that helps us keep it in its shape. Let's do 250 here. Also going to, yeah, let's give it even maybe. All right, so just thinking of some stuff here, right? So our mesh seems like it's twisty enough to be able to get what we want out of it, so that shouldn't be an issue. Let's also do one more thing here. Let's reduce the time scale a little bit. Let's do something like 0.25 and just let it kind of evolve a little bit more slowly and see how that does it. Oh, well, the problem there is that now our force is only being applied to it at the very beginning. So let's not go so far. Let's do 0.5, see if that does anything for us. Just going to bring it back up to where it was just so I can double check what's going on here. Also I was playing it back past real-time speed, and that's not always helpful. I'm wondering, so I'm going to leave these. I'm also going to put in a pop wind just to add that noise back in a little bit, just to give us some of that randomness. So let's do this. Add in some amplitude. We don't need any wind velocity or anything like that, but let's add that back in and see where that gets us. So that'll get us a little more noisiness, a little bit more randomness in this. Also, I'm going to, well, let me look at this again here. I want to just take a look at this again, because what it's really doing here is we're actually adjusting the rest lengths as well for this cloth. It's like getting bigger, right? So that's kind of a big part of this as well that we probably should be taking a look at. But let's do this. Let's take the stretch down and just see where that, I'm just going to take it way down and see where that gets us. Oop, too far. Let's do it to like 1,000. Yeah, now we're getting somewhere. All right, that's too far. So let's go up by a factor of 10. All right. So that's kind of interesting. The other thing that we could do too is we could kind of puff out that rest length, right? And the way that we can do that is actually by doing a Vellum constraint properties. So we can start like this. This, I'm just going to say, actually I'm going to get rid of the struts because I don't actually think that's going to be too helpful for us. So let's just say tall cloth block, something like that. Just so we have a name here. What we can do is we can go in here and we can grab, we should be able to grab that group. Actually, we need to name that group. Oops. So we have our stretch group here and we have our bend group here. So I'm going to say here for this output group, I'm just going to say $OS. So that's going to call this tall cloth block. We don't need to, what we could do is do stretch. I think we could do that. Is that going to work? No. So we need to do it like this. We're going to put little backticks around this. And then we could do that. So we could do $OS stretch. And we could say the same thing down here. We could say $OS bend. So that's going to put an output group for those. And when we come back in here, there we go. So we could say the stretch for the tall cloth block. And we could say the rest length scale. We could animate that, for example. So let's do that. Let's say from here to maybe 48. We'll go just a little bit. We're not going to go too far with it, I don't think. But I'm going to turn off the simulation. So we're at 48. Let's do 1.25 maybe. I don't know. We'll give it something. See how that goes. See how this works for us. But this should allow this cloth to stretch out a bit more and hopefully do something a little bit more interesting here. So let's see where this lets us go. Right, okay. Getting somewhere here. Let's also go in here and just say, let's do the same thing, but instead of going to 1.25, let's do it up to 1.5 and see where that takes us. The other thing I'm going to do is now I'm going to actually bring my timescale down a little bit. So we'll do 0.75. See where that gets us. Turn back on my simulation down here. You might not be able to see that, but there's a little. All right. I think now we're getting somewhere. So I'm also going to add back in that pop drag again. Oh, here, that's what I want to do. This air resistance shouldn't be at 1, and probably these shouldn't be at 1 either, now that I'm thinking of it. These should probably be at something a little less than 1. So let's do that. Let's set these all to maybe 0.5. Set this to 0.5. Now, the reason I'm changing that is because when you have your air resistance at 1, it basically just takes over more or less and just does exactly what you want it to. In our case, we probably want it to be a little bit less so that we're able to have some of these all these forces all work together. So here, this pop wind, I'm going to also put this down to 0.5, and then I'm going to put some pop drag here as well, and this I'm going to put maybe at 1 just to actually kind of give it that last bit of drag to try to slow it down a little bit. So let's do that, and I'm also going to maybe increase the size a little bit here just so we get a little bit more. Since we're taking this air resistance down, I want to make sure we're kind of countering that a little bit. So let's see how that works. Yeah, and then we can actually probably kick this up a little bit here. Get a little bit more noise in this. And I'm also going to adjust these curve forces a little bit here. I'm just going to hit middle. I'm going to middle click on that there. So I'm middle clicking on the air resistance. Shift middle clicking on it. And I'm just going to adjust these so that they're on for a little bit longer. So I'm going to grab both of those and just pull them this way a little bit. Open the animation editor up. And that should adjust them for all of them. So let me just double check here. We can see our keys. Yep. Looks like we're good. Those all adjusted. So now we should see this twisting force kind of get added in here for a little bit longer. And then we should kind of lose that. And it should just kind of float around. All right, so let me just change the length of this. We'll set this to be 120 down here. I don't need it to go too long, so that should be good. All right, I'm going to up the resolution of this just a little bit to see a little bit more resolution. So I'm going to change this down to 1, and let's see where that kind of takes us. Also going to just do this as smooth shaded just to kind of and I'm going to add in some normals here. Hopefully that'll make this a little bit better. It's interesting, we're not getting great normals out of this here. Just checking as to if we're getting our normals out or not. It does not seem like we are, which is interesting. It's okay. I can just do that down here. At least I thought that would work okay. Maybe not. Yeah, there we go. So now we're starting to get some of this twisting motion. It's kind of, I think part of what we want to do here is, I think we want to give it a little bit more to start with and then bring it back down from there. So maybe instead of going all the way to 0.5, I should have probably gone to like 0.75 for the force of this. The other thing that I want to check here, I'm just going to keep remeshing this down a little bit. Just want to get this into a nice, decent spot here. Yeah, so I actually have like too much noise going on here because it's actually just like crunching this up like crazy. So I think if I take this pop wind off just for a second, this will show more accurately what's happening here. Yep. Okay, so let's do this again. So let's take these air resistance and we'll just turn these up a little bit here. So we'll go up to somewhere near 7.5. Should work, something like that. Let's see where that gets us. I'm going to turn off these guides just for now. I'm also going to turn the suction down a little bit here on these. I think we're using the suction a little bit too much, so I'm going to turn that down. I just want to see what this looks like if we use something like a Vellum post-process. Yeah, that's looking a little bit better. So, all right. So what we're doing here is just giving it one bit of subdivision, one level of subdivision. So you can see here that we're going from our simulated mesh here to a subdivided mesh there. And we can obviously do even some more of that if we wanted to. This is still not that high resolution of a mesh, so we could do something like that if we wanted to, and then simulate on that. And then when we go down to our Vellum post-process, it's going to get even higher resolution, right? So obviously this takes a second to calculate and things like that. You know, it's subdividing it, the simulation mesh in real time. We can see that we're getting a lot of nice little folds and little details and things like that here. So that's starting to do something nice for us. We're starting to get a nice little result, which is, you know, which is kind of this sort of what we're looking for. I mean, it's not a one-to-one with what we were looking at. And the other thing there too, we have this little bit of what you're actually seeing there is that force reacting just on this one section here. So I think what we could possibly do here is could adjust that a little bit. And so I think this here is what, let's just adjust this for these curve forces here, and I can copy this to all of them. So what I'm going to do is I'm just going to, instead of having this be linear, I'm going to shift select all of those and then change those to be, I don't know, sure, monotone, cubic, something like that. I'm just going to adjust these a little bit, just like that. Then I'm just going to copy this parameter and paste the values to each of these. I could have them all linked, referenced together or whatever, but let's see if that helps to fudge any of that. Yeah, it's interesting. It seems like it did sort of get rid of it a little bit, but we still are seeing it a touch there. So that's kind of interesting. I'm kind of curious if we don't... let me select all of these, see if I can actually change them all simultaneously. That would be nice if I could. Yep. Okay, cool. So then I'll do that, and I'll also grab this one and move it over a little bit here. And then I'm going to actually make these lines a little bit longer so they're not so short. So let's do 0.5, and we'll just look at how these all stack up in here. So this one's kind of right in the middle at the origin. Actually, what I'm going to do is I'm going to do a match. I'm going to do a match size. And first we'll put it here, and this is going to move it right to the origin. If we do the same thing here, and then offset this up in Y, we can just offset it up whatever distance we want. So maybe 1.25, something like that. And then if we take this other one here and we do negative 1.25, cool. Oh, the other interesting thing we could actually do is instead of doing multiple lines, which is kind of silly, we are procedural here. So let's do this a little smarter. So if we do that, we should have all 3 lines based on 1. So now if I change this one line length, this is a way smarter way of doing this. They should all arrange like that. So let's do it 0.5 for right now. See where that gets us. I keep going up for some reason to get to the simulation. I have no idea why. All right, so now each of these curve forces, if we look at our guides here, they should be kind of all more on top of each other. So that's interesting. Let's just see what happens here. Okay, getting some movement there, a little bit of interesting stuff. Let's take a look at what this looks like with the Vellum post process on. Yeah, getting some interesting look there. Yeah, we're still getting these these kind of buckling. So let's do this. Let's adjust this up to like 1 or something like that. Just see where that gets us. Yeah, I like where this is going now. All right, so let's do this. Let's just actually make these even longer. So each of these forces are going to overlay each other, right? But they're going to have this overlap, and in that overlap, we can have it kind of blend those forces. So all of it will be getting. Actually, let me change this here. We'll say box cloth sim. Just rename that. So now what we could actually do is come into here into the Vellum solver. We could grab these forces right here. I'm going to turn this off. And let's just make sure these are nice and smoothed out like this. And then, yeah, that should be kind of interesting. Let's take a look at what that looks like. Okay, so I probably don't want them to overlap quite as much because then we don't actually get as much interesting detail in some of these areas, but it's certainly doing something sort of interesting. So let's just maybe go back to 1 and we'll let it do its thing here. Yeah, that's kind of cool. Getting some nice like curves here and things like that. It's kind of interesting. I'm also going to give these, I'm going to give it a little more cloth weight here. So let's up the density a little more here. And let's just see if that doesn't give us some more interesting weight to these particles or to this cloth. Because all the points hold a mass, right? So each of these points are going to have a mass on them. And so kind of the more massive they're going to be, the more we're going to get as far as like inertia and things like that. There's going to be more kind of behind them. They're going to do a bit more. So let's see kind of what that does for us. Yeah, now it's almost like we don't even need it to be adding that much force into it. We could almost just let it do its thing. The other thing I'm going to do is I'm going to adjust this rest length scale in here, this Vellum constraint property. So I'm going to turn this off so we're not simming. At this point, we're going to 1.5. Let's go all the way up to 2 and see where that gets us. I'm just kind of curious if that giving us a little more volume in here is going to help us or not. So let's see. Oh yeah, I think I like what that's doing too. Yep, I definitely like how that's going there. So now we're getting a bit more volume in there because if you remember, we're allowing these now the rest length to be able to get longer, right? We're doubling the rest length basically to add in a lot more space for this kind of this cloth to kind of puff out a bit more and breathe. If we look at this one, for example, and kind of look at what's going on here, really that is what's going on in this as well, because we're going from kind of one mesh to another, right? We're going from one mesh into this kind of cloth simulation mesh here. So yeah, it's definitely kind of some interesting behavior now. We're getting this kind of zero gravity cloth. Let me flip book this and just kind of see what this looks like kind of in real time so we can actually take a look at this a little bit more objectively and kind of say what's going on here instead of watching it in kind of this slower motion. So yeah, so at the end here we obviously see that it's lost kind of its force in that direction, and then it's just able to kind of float freely around and just kind of do its thing. And if we were to, again, we could probably still go a little bit higher with this simulation mesh to something like this. I mean, we have like 13,000 points here, so it's not like there's some crazy number or anything like that. We could simulate this. This is probably closer to actually where our final post-processed mesh is. And let's see what this looks like. Yeah. So let's see what that looks like now. Let's add another sequence in here and let this kind of play down. Okay. It's doing some interesting things there. Kind of got some interesting movements and stuff going on. Certainly getting closer to what we would eventually want out of it, but yeah, it's kind of doing something interesting. So the thing that I'm really kind of curious in this example here is how we're actually getting this look, right? Because we're kind of blending back and forth here, right? So what's specifically going on there? So I think what they're doing is they're starting, let's do this. Let's do a time shift here. And let's file cache here. I'm going to put this into hip.sim. Then we'll just name it $OS, and we'll just say tall cloth block. Something like that. All right, so let's save that to disk in the background. So we're going to save those. We're going to cache those out to disk so it doesn't have to calculate this Vellum post process. But what I'm thinking is, I'm trying to think here. Was it blend? Yeah, I think what we could do is possibly blend between the two of these. I've never done this before, so I've seen some people do this now, and it certainly is interesting. So I'm kind of curious how this is going to work. Oh, right. Got time shift this to delete the channel here, and we'll just do F start for that. Okay, so that is working. Yes. So we've got this ability to now blend between these frames, right? Which is kind of interesting. It's not showing these later frames because nothing's there. But now, okay, we'll let this finish up. Last few frames here. And let's take a look here. So I think what we could do is we could do this based on an attribute. We could do a float, attribute adjust float, and we'll do this from call this mask. And we're going to create it from a line in this case. Yep. That's cool. It's working. So we can do this based on both of these inputs together. And so what we could do here is I'm just going to put this to 0, 0. So these are now centered at 0. And I could make a width based on this. I'm just going to do it the end position. I'm going to set this to 0 as well. Start position, maybe I'll say negative 0.5, something like that. And I think I'm just going to copy this parameter, actually paste relative references here, and then just say minus 0.5. So then as we adjust one of these, which one is it? Not that one, this one. As we adjust this top one, you can get kind of this thing to move back and forth. And you can see here our remap ramp. Actually, we should probably make that a little longer. Maybe it's like 1. Sorry, we're visualizing 2 things here. I don't want to visualize that one. All right, well, what I'll do is just animate this. The other thing we'd probably want to do is do some sort of like a time ramp on this or something like that, but that's okay. Like you'd probably want to ramp this, but just kind of playing around with this, seeing how exactly we could do this. I think there's also a way that we could do this with attributes in the Vellum sim itself, but before we did that, I just wanted to play around with this and see how closely this would get us where we wanted to. Okay, so what I'm going to do here is just adjust this a little bit. Set this to be a B-spline. Just adjust this a little bit here so we've got maybe some better curves. We'll do that 3 and 6, something like that. Yeah, really this is just me being a little curious on if I can make this. Yeah, I guess I'll do it the other way. Oh, I'm not sure why that's going back. It's interesting. Mask. Where's my mask? Just gonna put in mask here just to see it. Oh, what happened there? Spamming enter. That was weird. All right, so we've got our masks here. Let me visualize that just so I can see what's going on. So I'm gonna click on that and just click mask. There we go. I'm not sure why that's... Oh, right, because I'm going backwards in time. That's my problem. Let me just reverse this. That should be what we want. Yeah, I mean, that's kind of something. It's not exactly what you would want, I don't think, but certainly interesting. Something like that. So just as a little kind of reminder, in case I didn't do a great job of explaining what I did there. So what I'm doing is I'm taking our Vellum sim, right? And I didn't, well, no, because I post-processed this here. So what I'm doing is I'm using this post-process, right, to help smooth out the simulation. Like when we get here, obviously this is our sim. It's a little crunchy looking. We do one subdivision depth on that, and that helps smooth it out quite a bit. Here I'm time shifting it, just setting it to frame 1. That keeps it at frame 1 the whole time. We're not changing our our geometry representation on this branch here. Then using the attribute adjust float, we're actually adding an attribute to this, right? So we're animating a mask attribute that's going to move up and down this. So as it moves up it, you can see right there, it's getting this kind of nice fall off added to it. In fact, we could probably go a little bigger with that, maybe 1.25, maybe 1.5, something like that. Make sure that still does what we're wanting it to. Yep, looks like it does. In fact, what I probably would do here is just make sure that this position comes up a little bit so that it's closer to the bottom like that. Then adjust this so that it definitely goes all the way up to the top, which it does there. Cool. All right, so now we've got this thing that goes up and down it. And so what that mask is going to be doing is coming into this blend shapes. And this is basically taking the blend between, I think that's fine. So what it's using is that mask attribute. It's setting the masking of this blend between these two shapes based on that mask attribute. And you can see it's from the first input here. Now we could do that from each input, but in this case, we want to do it from just the first one because the first one's static, nice and easy to kind of animate that mask on it and stuff like that. And so I'm going to turn off that visualization. There we go. And so if we just look at this kind of as is here, I mean, it's not quite the same as what's going on in the other one. The other one's a bit more interesting, but certainly is kind of this quick and dirty way of doing something like this to get an effect like this where you've got these kind of things moving out, right? It's a way of doing it. It certainly isn't the only way. There's a million other ways, but the cool thing is that you could, just like this person did, you could have it go like that, right? And then over here in the last, I don't know, few frames, we could just take this and I could just middle click on this to get our animation back, our animation editor. I'm just going to grab these values and put them back. So I'm just going to add another keyframe here and then go back to 120. And can I just copy this? Yeah, there we go. Copy and paste it. There we go. And so now we're back right there. And so what we could do is actually get the exact same animation almost here where we go like this and then have it go right back. Obviously this isn't, the most the most elegant way of doing it, but it is a way of doing it, right? So the other way of obviously doing some of these things would be to actually have it kind of explode out in the simulation itself. Which could be interesting too, and we should definitely take a look at that a little bit just to see how we could get this to kind of puff out in the simulation itself. Now, if you guys have any thoughts or ideas or anything like that, please drop them in the chat. I'd love to hear from you guys. Hopefully this is something interesting and we're getting somewhere cool. If there's something you're like, oh, I'd really like to see this with it, let me know. I'd love to hear that too. I always try to kind of start all the streams like that. So if you're new to this, please feel free to drop something in chat. I'm going to take a quick break and then we will be back shortly and we'll kind of, we'll go from there. But I am going to, I'm going to take a quick little break here and be back in probably 5 minutes or something like that. And we can kind of play around a little bit more with actually adding these attributes in the Vellum solver itself and seeing kind of where we can go with the solver and kind of allow us to be able to do this instead of it being a post process, which is cool and you have a lot of flexibility with, doing it in the actual sim will definitely give us some better results overall. So we'll take a look at that shortly. So if you have any thoughts or questions, drop them in chat while I'm away. I'll definitely see those when I get back. And I'll be back in a couple minutes and we'll go from there. All right, cool. See you shortly. All right, I am back, and yeah, thank you for sticking around. If you guys have any questions or comments or thoughts, please feel free to drop them in the chat. So let's take a look at how we might do this same kind of system with our solvers, with our solver being, kind of all of this happening in the actual solver as opposed to doing it after the fact. So let's take a look at how that exactly would work. So we have, we're going to take the same simulation here, but I'm going to just make another copy of this solver, and we're going to do this over here. So we'll just say Vellum, we're just going to say this is like a custom kind of setup. Cool. All right, so let's just move this over so we can see that we're kind of doing this in both of them. Great. All right, so we've got this here. What I'm going to do is I'm not going to animate these curve forces for right now because we want them all to be able to be like, they're not going to be the thing that's moving the simulation per se. Like, it starting up isn't going to be determined by when this is active. So what I'm going to do is I'm just going to delete this for right now, set it back to defaults for all of them. And we'll work with what the exact settings we want when we get there. Everything else, I think we're going to keep mostly the same. Oh, I turned off the pop win for that last one. That's interesting. The other thing I'm going to do is I'm going to get rid of this Vellum constraint property because we're going to adjust that rest length as the particles kind of are released into the system, right? So what we're going to do first is so what we're going to use is this attribute called stopped. And this is a pop attribute. You can see right here it's used by Vellum. It has a few different ways of working here. So what it does is if it's 0, the particle is free. If it's 1, the particle can rotate. If it's 2, the particle can't rotate, but it's free to move in space. And if it's 3, the particle can't rotate or move. So those are the ways that we're able to control whether it can rotate or move. Either it can do both, or just whether it can do one or the other. So I think the interesting thing here is that, yeah, it says it's via bits 0 and 1. That's interesting. That's a little bit of binary talk. It's interesting. Just realizing how this might exactly work, but like behind the scene. But the integer is stopped, and these are the values that we want to put with it. So what we want to do is set these all stopped to 3. So let's do that. So let's just do a pop wrangle. I think that'll be easy enough to control. And let's do this. So we'll say at stopped equals 3. And then we'll just do a quick if at frame, capital F for frame, that's one of the inbuilt properties. If frame is, we'll just say is greater than 6. No, let's do greater than 12, just so we've got a good few frames here to know that it's not doing anything yet. So if frame is greater than 12, we'll say at stopped equals 0. This is just a quick check to make sure that what I'm doing is right, so that we can make sure that this is actually behaving and listening to me. So let's try this. Looks like it is. So from frame, it's just going to twist itself into little spheres almost. So from frame, this looks like at 12 it should start. And there we go. It starts going. So that's cool. That's doing what we want it to. However, we might want to do something a little bit more custom here, right? We don't want to specifically say, you know, what exact frame all of them need to switch on, right? So we want to do something that's sort of similar to this over here, except we want it to be able to kind of set when it's going to release, right? When it's going to release from the simulation. So instead of doing that down here, let's do the same thing. We'll do a float, I'll type float here, and we'll do an attribute adjust float. I'm going to use this, oh, sorry, not float, my bad. I'm going to do attribute adjust integer. So let's do this, and we'll just wire that in between. And what I'm going to do is say set release frame. And so this release frame is going to allow us to be able to set up where specific when and where this will release from. So I'm going to do the same thing. I'm going to grab a line. I'm going to hit enter here in the viewport so that we can get this little helper here. So we're going to put this in here, move this around. We don't actually want to be on the solver because that's slowing it down. I'm like, why is it it's not moving so quickly? It's because the solver is trying to calculate it. So let's do that. We don't want it to be variant. We want it to be release frame, like so. Let's say it's between 0 and 24 for right now. We can visualize this by clicking this little button right here. This should visualize it. Oh, my visualizer's off down here, so we're not going to see it. So we can see here now these like stratified layers are the frames where this is going to be released, right? So each of these is representing one of these 0 to 24 values. So that's working out great. That should do exactly what we want it to. So what we should probably do as well, is do the same thing here and do attribute adjust. Oops. Sorry. I'm just going to type in integer. A little easier. And what I'm going to do here on this one, just add a little bit of noise into it. Add some noise. We're going to use the same exact thing, the release frame. And this will just make sure that we're getting some nice little noised up values here. Now, obviously that's too much. So we will adjust that here. So maybe something like between maybe -1 and 1. And then we'll change the element size down a bit so that we just have a little bit of like, let's see here. Yep, that should work. It's a little more than I would want it to be. Maybe what if we just do random? No, it's about the same. Just thinking this might be fine, but it feels a little much. I guess it's a little tricky because it's an integer value, but that's okay. Let's try that. We'll see how that goes. All right, so these are going to represent our release frames as we go through here. And we only have 24, so I guess it makes sense that some of these noises are a little tricky here to make work. So we have this here. Oops. We noise it up a little So from that to that. Still feels a little too much. Just maybe do it like that. Okay. I'll just do it like that. That'll give us a little bit of noisiness here. I don't know why this feels... Does not feel right. It feels a little better. Something like that, maybe. Okay, cool. Just have a little bit of noise there. Not so much. Cool. All right, so now if we come back in here, if instead of saying if frame, so in our pop wrangle right here, instead of saying at frame is greater than 12, what we could say is if frame is greater than at release frame, which this should now have if we look at our Vellum object here and we look at our, sorry, I'll make this a little bigger. If we look at our Vellum object, look at our geometry, we should have a release frame on here. Release. Like I said, we won't have a release frame on here. Let me just make sure what is happening here. Reset the simulation. Yeah, I see a release frame. Maybe I just need to type, need to type the whole thing in. Duh. Okay, so if the frame is greater than the I at release frame, that's going to release now. So let's take a look and see if this will actually work. I'm going to turn off this visualizer and let's just see what happens here. Yep, sure enough. It's doing its thing. Cool. Okay. So now what we're doing is basically we're using just a couple simple lines of X here with some attributes that we made, and we're getting this release as it goes up like this, right? So it's kind of releasing as slowly as we kind of raise up. The other thing that we could do here too is could kind of smooth this out a little bit. So what we could do is we could sort of speed this up. Let's take a look at this here. See what we can do. So what we should be able to do here is I'm just going to do this and set this to B-spline. We'll get a little bit of a smoother spline here. So if we do something sort of like this, should have it quickly start and then kind of ramp up in the middle and then slow down. So let's see how that works for us. Actually see that attribute there. So another thing I was sort of thinking too we could do is we could actually have we could actually transfer velocities onto this cloth to start with. And then that way we're not worrying about this as like a force that's in there, but we could give it a start velocity to these points. And that actually might end up being a better solution to this whole thing. So I'm kind of thinking that might be a good way of doing this. So let's try that. Let's give it a shot. See if we can get anywhere better with that. So what I'm going to do is I'm actually going to turn these off for right now. The other thing we're not doing is actually stretching this cloth out yet. So we haven't adjusted that at all yet. So that's a whole nother thing. But that's okay. We can get there. And so let's do this. Let's add some velocities onto this. So let's create a couple circles. We'll do this in the YZ plane. We don't want to do it as we'll do it as an open arc, I think. That should be good. And let's do this. Let's do a poly frame. And let's do the tangent as V. I think that will get what we want out of it. Yep, we've got our V velocities there. Let me just do this instead. We'll just grab V like so. Then we can actually see it a little bit better. I'm going to turn this off, and then there we go. Those are a little easier to see. Cool. Okay, so we've got some velocity there. So what we could do is we can just do this. We'll take this, make it a little smaller maybe. Just want to see where we're looking. Oh, no, actually, yeah. So we've got this. We're going to do more or less the exact same thing that we were doing before. So let's grab this and say 1. Then we will do can just do a straight up transform with this and say, how much do we give offset on these? 1.25. Now, the reason I don't need to use the match size is because this is right in the center here, so we don't need to worry about that. So translate, let's do 1.5. Is that what I said? I already forgot. 1.25. And I'm also going to I'm going to rotate this 180 degrees, so those should face the other way. Yep, cool. And then I'm going to do the same thing, except move it down by 1.25 here. And then we can do a little merge, like so. So that's our velocities there. And we can obviously change this to be a bit more smooth. So we could do something like 24. It's going to give us a little bit smoother option there, a little smoother vectors. So let's now take this and transfer it onto our geometry. So we don't have any velocities here, right? These are all at 0. Velocities are initialized to 0. So let's do an attribute transfer. And we want to take this and transfer it onto this. And we're getting somewhere here. Got a lot of yellow things happening here. So let's just reduce this a little bit. Oops. There we go. We'll do it at maybe like 0.4. Just so we have a little bit more visually happening here. So we're just going to transfer velocity over. That's all we need on the points. Let's go to conditions here. And these are going to be how we can actually do our sample count. So the maximum sample count is going to be, I don't know, could do 10 if we wanted to, sure. And we could give a blend width here. Let's see, we should be able to get a little bit more blending width. Oops. All right, so let's do this. I always forget exactly the specifics of this. Let's just do 10 samples. Yep, we want to give it a maximum distance of whatever distance here, maybe, I don't know, 1.5 or something like that. It's probably about as far as we want it to go. Maybe we'll just say 2 to give it a little extra. Let's just see what we've got specifically here. Yeah, that's our kernel. Okay. There we go. I think we're getting somewhere now. Just make these a little longer just so we can definitely see what's happening now, because they were a little too long before. Now they're looking a bit better. Hey, look at that. Jeez, I get like one crash a night on this. It's so stupid. Anyways, let's pull that back up. Oh, that's the wrong one. That was not the version I was using. Sorry about that. Man, the classic. It's a classic crash. The heck? All right, let me make sure I'm in the right version. There we go. That's 688 is the one I was using. There we go. Hey, Ninehole, nice to have you here. Yeah, we were I was in a little meeting earlier with some instructors and stuff like that, and and we were talking about SOPs and LOPs and things like that, and I think that's an interesting thing there. He's saying basically that he's found that switching from LOPs to SOPs with your attributes displayed, that you can have a crash. And so that is interesting for sure. Yeah, that's definitely, yeah, I can't, I'm trying to think of how to answer this in a reasonable way. Yeah, it's definitely an interesting issue. And what I'm hoping is that in future releases of Houdini, that there will be things that will help to make that switching process easier. I know that everybody knows that it's kind of a pain because you need so many windows open and stuff like that. So I know that the developers are aware of that. Yeah, that sucks. Like, I haven't really run into that personally, to be honest. I think a lot of it depends on a lot of the crashing and things like that in that case really relies on kind of a mix of your graphics card drivers and things like that. It's the OpenGL viewport that could be at fault there. It could be some of the visualizer code, right? There's a lot of different things happening there, right? And you're going from the Solaris viewport, you're going to the Houdini viewport, and the Houdini viewport is different than the Solaris viewport. Like, yes, they're both OpenGL, but one is a Hydra delegate and one is the traditional Houdini viewport. That's why it changes. So there's some really weird stuff there that certainly are pain points. And I know that the developers and in past releases and things like that, they've talked about wanting to really revamp the viewport. And that's an ongoing project that that Side Effects really wants to tackle. And I know they've spoken that publicly. So, so I think all of those things together might be, might be something to think about there. But yeah, it's definitely an interesting question. And I don't really have like here's your silver bullet magic fix type thing. But yeah, that definitely is unfortunate. Yeah, the viewport revamp will be a nice thing. That's something that they're working on, and who knows when that'll come. But it's something that is sort of like, there's all these things, right? There's things that we're aware of that need to get changed, and so there's kind of this constant like, you know, there's things that kind of are all working together to make some of these pain points, and certainly making USD easier and a bit more transparent to work with is always going to be a thing that we're trying to work with. So yeah, it certainly is an interesting comment, but yeah, that's probably about all I would even have to say about that. I don't really have like oh yeah, do this and it'll magically be better. But yeah, that's sort of definitely unfortunate, but all right, so I'm going to just kind of tweak this a little bit here and see what we can get going. Sure, something like that. I think will be good. So let's try this and see if this will give us something that we like a little bit better here. Oh, right. I'm not giving it as much velocity as I was before, so it's definitely not gonna like that, because it seems like this is a gigantic what's the word? This is a gigantic vector, but it's actually not. It's only one in that direction. So what I should do here is multiply that vector. So let's do that. So I'm just going to do an attribute adjust vector, just so we're not doing coding type stuff. That's kind of the reason these exist, so we can make these bigger and better. So we're going to work with V here. That's good. We're already working with that. And so what we're going to do is just do the length only. And we're going to say, nope, not subtract. We're going to say multiply. And what we can do is multiply it by, I don't know, 5. Let's just do 5. It'll be good. And we'll come down here and we'll see kind of where that gets us if we're doing 5 in those directions. It's interesting. Surprised that we're getting. Let me actually just turn all these forces off here, just to see what this velocity does out of the. Oh, that's really interesting. I would have thought. Okay, so what I think it's doing here, which I hadn't really considered, but this is interesting. This is an interesting little sidebar here. So we have these velocities, right, that are happening, but the second that the sim starts, those velocities actually get canceled out, which makes sense, I guess. I'm just thinking that it's, right, we have these pretty big velocities here, right? So 2 and -2 and stuff like that, probably all the way up to 5, right? So what it's doing is it's actually, okay. So what we actually want to do is we're just going to say, instead of calling this V, we're going to rename this. We're going to say, we're going to do attribute rename here. Just going to go from calling this, we're going to go from V to V. Why don't we just call it V rest? So this is our rest velocity, we'll just call it. And so what we can do then is, since we have a different velocity here, we're not going to copy over V, we're going to copy over V rest. And so now we will have this V rest attribute and our V attribute that will come in here. And so it's not going to operate on vrest because it doesn't know that exists. Now it has v previous and v last and all these different things, but vrest isn't something that it's going to use. So what we could do here is, in our pop wrangle, when we get to this release frame, what we can do is say v at v. No, because this is going to set it each time. Oh, yeah. instead of doing greater than, I'll just say equal to, because we don't need to say this each time. So this will just do it when it's equal to that. It should switch it back to stopped, and it should stay stopped 0. And then we're just going to say v at v equals v at rest. So this should be instantaneously switching that over. So let's see if that does it or not. Hopefully that will. Actually, you know what? Before I do this velocity thing, I just want to make sure it's actually going to work. So let's just turn these guys back on just to make sure that this is actually going to release and stay released. So let's just do that real quick. No, it is not. Oh, right. Because I'm actually calling stopped here at 3. So that's something we need to change. I need to actually set this attribute outside of this. So I'm just going to get rid of this. And we'll bring this up. And I'm just going to add one more attribute here before it comes in. And I'm just going to say attribute create. And we'll just say this is going to be a point. It's going to be an integer. We're going to say stopped. And the value is 3. So now that should have a stopped attribute here that comes in at 3. Stopped. There we go. And so then this pop wrangle should just work on it and go from there. So let's see. Oh, right. So the problem is I think I had it set to be 0 to 24 and not 1 to 24, which would make more sense because we don't have a frame 0. So let's try that again. There we go. Doing what we wanted it to, and great. Okay, so that's all working. So let's turn this off. Let's uncomment this. So now we're going to add in that velocity. We're going to set it equal to rest at the release frame. So let's see if this works. Oh, actually, I'm going to turn these forces off again just to see what's actually happening here. Nope, we're not getting that. Interesting. Why is that? Everything else is working. Let's take a look. Oh, I just mistyped it. V at V rest is what I wanted to say. Now that should work. Let's see. There we go. Interesting. We're not quite getting what I would want it to do. It is doing some stuff, which is kind of interesting. Let's bring this over here. We'll grab another post process and whoop. Yeah, I always love it when it does that or it loops around. So let's shift click those, grab that. Just want to see what this looks like here. Yeah, it's a little too crinkly. We'll see. We'll see what we want to do here with it, but I'm going to try to turn off this noise so that it all kind of releases a little bit more. Yeah, it's interesting. It's because there were so many random points in there that are not releasing that it's sort of freaking it out a little bit. Interesting. Okay. Well, we're getting somewhere here. Let's just see what we got. A little too fast. Let's give some pop drag, a little bit of pop wind, just to slow that guy down a little bit here. Okay. All right. We're getting somewhere here. Let's just adjust this. So instead of looking at V, we'll look at V rest. Just say V rest. All right. Let's turn that on. And we're going to make that a little smaller again, just to visualize it a little better. So I think what I'm going to do is actually move these up even a little higher to -2. Okay. Just want to kind of even these all out a little bit so that we're hopefully getting kind of these equal areas of force on this. So let's try that. Yeah, it's kind of interesting. It's doing some of that weird blobby stuff. So the other thing that's happening here, I think, is we're getting a little bit, maybe a little too much on the pop wind. So let's tone that down a little bit here. So let's cut that in half and see what that gives us. So we're not seeing so much of that pop wind. And I'm also going to adjust the pulse length on that. Let's see if we can see some guides here actually too. That'd be kind of interesting. Yeah, make the swirl size a little bigger. Hey, KG. Yes, welcome. Yeah, I'm kind of doing a few different things here. We originally, you could go back and watch some of the other stuff, but yeah, what we're doing is kind of playing around with doing some, I'm basically taking some of these forces on here. I have a rest velocity basically that I'm bringing in, and there you can see that's like kind of the forces applied to the mesh, right? So each point's getting sort of some random noise applied to it. I actually want to random it up a little bit more, but what that does then is it activates throughout the time, over time using this stopped attribute, and so it releases it based on if the stop attribute is the same. This release frame is the same as frame. So as it goes like that, kind of releases it into the simulation. So it's kind of interesting, some interesting stuff going on. Yeah, what awkward poly, you asked a question. Does it activate the velocity in Vellum on different activation frames as well? Or like RBD, only first frame? So you need to introduce the velocity by active frame. Yes, exactly. That's what it's doing. So because we're using this, I have a second Houdini open here. I'm just gonna close that. That's my other version. Because we're using the, I'm gonna pull open that help thing again. We're using that stopped attribute, right? So here, let's do Vellum attributes. This is a great help page if you're messing around with Vellum. This one right here. So sorry, I'll try to not be in the way of this. But if we take a look here, these are all the different attributes. But when we look at the sim attributes here, we can look dynamic state. There we go. So stopped. This is the one that we're using. And so we're using it to start. We're using it in this 3 value. So the particle can't rotate or move. Then when the frame is crossing when the release frame that we're creating here, we're creating this release frame right here, and we can visualize that like so. There's our release frames, and we could adjust that as needed here. Maybe you want to tweak that around a little bit, whatever. Those release frames are going to be where that activation happens, right? And from there, once it goes past that release frame, then we're allowing it to go into this stopped 0 state, which is basically releasing it. Now, Awkward Poly, what you were saying was, does this, because it's in that stopped state at first, once it hits frame 2, 3, 4, whatever, it tries to calculate that velocity. So that's, for the whole mesh, because because the whole mesh is actually active. So I don't think that there's actually an active state in here that I was looking for. Those are collisions, targeting. Type. Yeah, no, I don't think there's any other stuff in here. Like, I don't think this has an act. Let me just double check. I don't think it has active on here. Hello? Don't want that. Yeah, doesn't look like there's any active that's showing up in here. So that usually is what I would think is like, oh, we set it to not active, and then when it's active, it's going to come in, but it doesn't have that attribute that it looks at. So I think in this case, because it's in the stopped, where is it? Because it's in this stopped state, it's still calculating it and things like that, but that's like that sleep state, right? Also the auto sleep and awaken both will be the things that mess with that attribute. So you could also use there's a pop awaken SOP, I believe, to do stuff with this with that stopped attribute as well. So I think there's a pop awaken, and this has some different things like where nearby particles or volumes or whatever. So you could also do it that way, I guess, too, where you could pop awaken it too. I mean, that's certainly something you could do. You could set up a volume and animate that volume. Certainly possible. Lots of different ways, obviously, you can do everything. But I think that this is going to be a pretty simple, pretty easy to understand way of doing that. So hopefully this is pretty clear what's happening. I've turned off these curve forces because we don't need those really anymore. We just have a little bit of wind and drag in here. You can kind of, mileage may vary. Maybe we'll turn the drag down a little bit. I don't know. But yeah, so what we're doing is we have to pull this rest velocity that we've created into this, into the actual velocity. The other thing that we could do here too is if we look at the rest velocity, I'm just thinking how, is there one with these where that pushes out more? I can't remember. No, that's all the way in. No, I don't think there is one. Unless I do, no. So I think honestly you might want, well, it's probably fine, but you probably would want to adjust the direction of this. This vector. So you'd probably want to add maybe in another vector to kind of push it in or out more, depending on how you'd want that to actually to work. That's kind of like that suction force that we were doing before with these with these pop curve forces. It's got this like suction and orbit and all that stuff. Like those are kind of the same ideas that you'd want to like push or pull those vectors in and out to kind of make that movement a little bit more what you want, whether you want it to push out or kind of slide in a little bit more. But what I would probably do is down here, once we get it to this point, probably just add, I'm going to get rid of this one because I don't think that is really helping us at all. I like to usually add noise to things, but I think that's not actually helping us. Now, another thing that you could do is, I was thinking maybe instead of doing the release frame as an integer, you could do it as a float. But since we're doing time and all that kind of stuff, like I don't really think that there's going to be, I guess you could do it that way. If you're doing it on a float basis, you could actually do it that way. Let's see here. Let's try that actually. So instead of doing an attribute adjust, well, it's fine for right now, but that's another thing you could try. You could try doing this same process here with this release frame and do that with a float instead. And with the extra sub steps in the solver here, because I think we're at 2 sub steps, you actually are getting in between frames. So you might actually get a smoother motion if you do it with a float. So it's kind of my bad. I was thinking the frame makes the most sense, but we're actually working kind of on a subframe level here. So whatever, you could kind of tweak that a little bit. What I'm going to do though is do an attribute adjust vector, and just on the velocity here, I'm going to just add in some noise, and we'll do, I think 0 centered is going to make the most sense. Let's go down to this. Oh, actually it should be v rest. So let's do that. We'll do 0 centered, and we'll see that this is now going to adjust that. I just want a little bit of like little choppy noise to be added into this, so it's not so smooth, but something like in there maybe. We'll just say direction only. We don't want to noise up the actual. I guess we can do both. That's fine. All right, so we'll give that a little randomness in there, something like that. I don't know. That's good. A little bit of random noise. Never hurt anybody. Okay, so let's take a look at this. Yeah, I'm just going to look at the actual solver, so I'm not putting it through that post process, and it'll actually play back a bit quicker. I actually don't like how that's collapsing on itself. I'm just going to do this at a little bit less, maybe. See if that helps us at all. Oh, right. The other thing that I wasn't doing here is letting it expand the actual the rest length. So that would be a little different how we would do that. And oh, actually, you know what? No, we could just do this. We could do Vellum constraint properties. And I think if we do the same thing, we had that rest length set to 2. Let's just try this because this should work. And it's not, so when it's stopped, it's not gonna, it shouldn't try to do that. Let's see. Let's see what happens. Might work, it might not. Let's see. Oh, nope. No, didn't like that. Just trying to think here what we can do, because if you think about it, we've got that attribute on our points, but we need to move it over to that like release frame attribute. We got to move it over to our constraints, which is a little trickier to do. So let's take a look at that. So we have this release frame attribute. And what we want to do is okay. Let's do an just do an attribute copy here because we should have all of our same points here. And what we're going to do is we're going to do release frame. Type it correctly. There we go. Okay. So because we have our geometry having one-to-one points to primitives, we're in a good spot here because we can now attribute copy this over, right? And it's going to have the same number of points in this geometry here, which is 13,000, as in this geometry here, which is 13,000. Now this is our constraint geometry, so it's a little different, but we're just going to copy that over. And then we can do an attribute promote here. And we'll go from point. We're going to just grab the release frame because we don't need it on the point. And we're going to say we're going to bring that to the primitive. And what we're going to do is average that. That should be right. And so now we know that those primitives are going to be released kind of at the same time as the points are. And what I'm actually going to do is say maximum, I think, minimum, because we want it to release as soon as it possibly can, not at the very end of it, right? So now what we should be able to do is come into our solver here. Let me just put those there. Come into our solver, and we can then take here on our Vellum constraint properties, we should, or actually, just trying to think here. We could do a Vexpression here. I just sometimes feel like this doesn't always do what I want it to. I'm just looking at these and thinking, okay, yes, what we can do is, yeah, so this is just passing through. So these are the, this is how you actually end these. You don't actually put these in as, so like this right here is just going to set the same rest length. All right, so let me try this. So if we're going to do, let's just do this as an if statement. If at frame, and this is going to continually look at that. No, that's fine. Okay, so we say at frame equals I at release frame, which is the same as the other attribute that we put in here. Oops. What we can do is, let's try this. Let's just say rest length, and we'll just multiply it by 2 times equals 2. Let's see if that works. I'm not 100% sure that that's going to work, but I don't know if that needs to be on or not. Let's just keep it off for now. All right, that's interesting. Let's look at our constraint geometry and let's see if our rest length is changing at all here for any of these. All right, they should all be released by this point, and I'm not seeing that change at all. So that tells me that it's not working. So let's try this. Just make sure that that is not what's needed. Okay. It is what's needed, although it's freaking it out. Let's just try something a little smaller. Right. Wrong thing here. I want it to be rest length scale. Okay, let's try this. So let's do rest scale equals, let's do something a little bigger. Let's do 2. See if this works. All right, again, let me try this. Nope. All right. I don't know why I have such a hard time getting this constraint properties of expression thing to work. I don't know why. I must be missing something really dumb, but that's okay. I can do another, oops. I can do a geo wrangle. And we're going to do constraint geometry. And that should be good. All right, so I'm just going to copy more or less the same thing over here. But what I'm going to do instead is, instead of saying rest scale like that, I'm going to say at rest length. And this I'm going to say, oops, times equals 2. That should work. Let me just make sure that I'm... Okay, let me just do that here. I'll do myself. I think that'll work. Let's see. Nope. Oh, that's why. Primitives. Let's do that. Should be on primitives, not on points. Try that again. Yep, that is actually working. Okay. Not exactly what I'd want, but it's definitely doing it. Let's try this. Yeah. That's sort of doing what I would want it to do. Yeah, I think that's kind of interesting. Something interesting going on there. So yeah, so this is the way that you could do that in in the solver, releasing the frame, releasing the simulation based on frame, adjusting the geometry constraint, or the constraint geometry as well, to make sure that that's allowing it to stretch a little bit more. Another thing that you could do as well is age your you could age your constraints, and as they get older, starting from the frame, this release frame or whatever, if you're past the release frame, start adding one frame to it or whatever, to age it. And as it goes over that whatever time span, you could have it the age could control how long those constraints get. So they might not instantly puff out, but it might over 6 frames or something like that puff out into these longer, these longer constraints that are going to actually, make the simulation kind of do, kind of expand or do whatever. But that's another thing you could do as well, is add in a constraint, this age to the constraints, and have that drive some of that action. So I think that is where we're going to end this for this evening. Unless anybody has any other questions or anything like that, please feel free to put it in the chat. I'm just going to kind of talk for a little bit here. But I think we're getting some more interesting with this. I think you can kind of see different ways of doing this. We had kind of our fully simmed way. We have our, kind of funky blend shape way here, where we can kind of take this simulation and do with it what we want. So obviously that's kind of a workaround and a cheat in some ways, but gives you some ideas hopefully to start with, as far as like where you might go with your simulations and ideas and things like that. So obviously this usually is not a thing where we're trying to get some grand finished product done, but just getting some ideas out there, kind of doing a little kind of on the fly sketches and talking about how things are set up and ideas for how to work with things. So hopefully something interesting, at least to understand and kind of play around with. But yeah, I think that's where we'll end it for this evening. So I think we'll just say, oh yeah. How you loop it to spin back to a similar rest. Yeah. So that's actually what I'm doing here with this blend shapes. And you could certainly do something similar to that. You could also give it like a target. Oh yeah. There's a loop function. But so this blend shapes right here is actually doing something really similar. It's doing something interesting that you could at least kind of experiment with and see kind of how you might want to do this. But what I'm doing here is I'm actually using a mask attribute to drive this. So there's a mask attribute on this. This is just the rest geometry, right? So we have a mask on it that animates up to the top, and then shoots back down, right? And so this mask attribute is actually driving this blend shapes. And over here is our cache, right? So this is actually our simulation, and it's all cached out and everything like that, right? Like this. But this blend shape is actually blending between the two. So we're using this set from attribute. We're using this mask attribute from the first input, and using this to kind of drive this sort of quasi fake version of the other one, right? It's not actually right, but it's kind of interesting. There's some interesting parts to it, right? So I think the top is a little goofy how that kind of animates in. It might just take too long to get up there, but this is sort of a similar idea here, where you're kind of pushing out these you're kind of taking this rest, blending it into an animated geometry, and then blending it back. So this is kind of an idea for how you might go about doing something like that. You could also just use this the other way too, where you're starting, from your simulation and then blending just to the very end of it. So what you would do there is, so instead of having it start like this, you would just have it start with the simulation, and you would do something like this, and it would just go like that and kind of animate around. And then you could just snap it right back. So this is another way that you could do it, right? And so you could take these, the same blend shape thing here. I'll just copy this over, put it over here, cut those wires. And we have our rest geometry here. I'll take that, and I'll also take this mask. And we should be able to do the same thing here. So if I do yep, that all seems right. So let me just do a file cache here. Right. Yep, I see what you're saying. The rest would come from the bottom. Yep. I'll just say custom velocity cache. And let's just save this to disk in the background. And so I'll let that cache out. But no, it's no problem that you missed that. It's actually good. I should show this on this one as well, because it certainly is something you could do here. And so if you take out that that part of it, that makes it a little bit more interesting, because this original one here, where is it? This mask. So this one, here's my animation. So if I take this and copy it back over there. Okay, cool. So, this one is fine. It's not great, but it's doing some similar things, right? But over here, we could just let it simulate out at the very beginning here, which it's going to do, and just, oh, weird. Okay. Yeah, that's doing a weird thing. So I'm going to just pull this time shift over as well, and just, oh, right. It's, I need it from this post process, because this is actually subdividing it. So I need that because it's not the right geometry. That's why I was freaking out. But yeah, so what you can do here is this will do that simulation, right? It'll release itself, do its whole thing here. And then we can just snap it right back into place. Like that. And then we'll have it go. So that's kind of interesting, something sort of different, but, and this was coming from this idea here that we were seeing. So it's honestly fairly similar. It's not that outrageous from what it's doing here. And this will actually zip back in. Yep. So I think we're getting pretty close to what this, effectively was. And so hopefully that's kind of interesting. Obviously you could slow that last part down. It's a little on the intense side. So if we go into this mask and just adjust this here, this is kind of the nice part about it as well, is right. You could come in actually, manually adjust these things, right? So you could, oh, that's weird. Why is that? Sorry, just figuring out why this is. All right, that should be maybe something. Let's see. Yep, there we go. So there's our little cloth sim, and then it just zips back in. So that's kind of interesting, I think. So there we go. We've got kind of our looping 0G simulation here. It's 120 frames, and you could certainly put textures and all sorts of other things on here. You could kind of play around with, any number of different ways of making this work. Obviously, play around with the velocities quite a bit more and get some more interesting shapes and patterns and things like that. You could also put in constraints that would do other things like little cinches or things like that, put in just a section where it's going to, make your constraints shorter in that area and kind of cinch it together. So there's lots of different things that you could do with this. Hopefully this gives you some ideas of how maybe to make something like this and have some interesting controllability for kind of blending it back to its rest position. Now, obviously it's a bit of a brute force way of doing it. You could also probably do it within the simulation itself, like giving it like a position to kind of get each point back to, but it's never going to exactly come back to rest in the exact same spot, especially if you're doing it in some sort of simulation, unless you're really explicitly like making the points move into some spot. But anyways, hopefully this is an interesting little exercise and idea. And I think that's where we'll leave it for this evening. And thank you guys so much for joining. If you're watching this after the fact, please feel free to yeah, no problem. That's kind of what I the whole reason for this is to all kind of figure something out together and work through things and ask questions and stuff like that. So yeah, I'm glad seeing someone's thought process is helpful. Oh yeah, no problem, KG. Thanks for joining. Feel free to go back and check out some of the earlier parts of the stream. There might be some interesting little tidbits in there as well. But thank you guys all for coming and being a part of this. If you watched after the fact, please drop a comment in the comment section below if you're on YouTube. My brain's shutting off because it's 10:30. But that should be hopefully you guys got something great out of it, and I will see you guys next time. Thanks so much. Bye everybody.